The first images from the Vera Rubin Observatory have already revealed something that has astronomers completely stunned. In just 10 hours of observation, this revolutionary telescope discovered over 2,000 new asteroids, captured millions of galaxies, and found a stellar stream longer than our entire Milky Way galaxy that nobody knew existed. The Vera Rubin Observatory sits 8,684 feet above sea level on a Chilean mountaintop called Cerro Perched, representing the culmination of a 20-year, $810 million effort that's about to transform our understanding of the universe. Named after astronomer Vera Rubin, who provided the first convincing evidence for dark matter's existence, this observatory isn't just another telescope. It's a time machine that will create a 10-year movie of the entire southern sky. What makes Rubin so extraordinary isn't just its size, though its 8.4-meter mirror impresses. It's the combination of speed, sensitivity, and scale that sets it apart. At the heart of this astronomical marvel sits the largest digital camera ever built for astronomy, a 3,200-megapixel monster that weighs over 3 tons and stands roughly the size of a small car. To put that in perspective, this single camera packs more pixels than 260 modern smartphones combined. The engineering challenges of installing this camera were immense. Picture trying to position a car-sized, incredibly delicate instrument with millimeter precision while perched on a mountain in Chile. Project scientist Robert Lupton noted they managed to place the camera within just 3 millimeters of its target position through what he called dead reckoning. But even that tiny deviation initially caused problems, creating donuts of light instead of crisp star images due to the camera's incredibly wide 3.5-degree field of view. The journey to this moment began in 2001 when the project was first proposed as the Large Synoptic Survey Telescope. Construction officially started in 2014, and by 2019, the observatory was renamed to honor Vera Rubin, a fitting tribute to a woman who revolutionized our understanding of the cosmos, but was controversially never awarded a Nobel Prize for her groundbreaking work. Vera Rubin's story itself is remarkable. Growing up in Washington, D.C., she became fascinated with astronomy while watching stars from her bedroom window. Her parents encouraged her interest, and her father even helped her build her first telescope. But her path wasn't easy. Princeton University rejected her graduate application simply because of her gender. Despite these obstacles, Rubin persevered and, working with colleague Kent Ford in the 1970s, made the discovery that changed everything. They found that stars at the edges of galaxies weren't moving as predicted. According to our understanding of gravity and the visible matter we could see, these outer stars should have been moving much slower. Instead, they were moving far too fast, so fast that galaxies should have been flying apart. The only explanation was that there had to be much more matter present than we could see. This invisible matter, which we now call dark matter, makes up roughly 85% of all matter in the universe. Now, the observatory bearing Rubin's name is poised to continue that legacy of discovery. The first images released in June 2025 showcased the telescope's incredible capabilities across different types of cosmic objects. One image captured the Virgo cluster, composed of over 1,100 overlapping frames totaling 3 trillion pixels and encompassing approximately 10 million galaxies. Another stunning view showed the Trifid and Lagoon nebulae, created from 678 exposures taken in just 7.2 hours. But perhaps the most exciting discovery came later, in October 2025, when Rubin detected something that had been hiding in plain sight for decades. Around the galaxy M61, located about 52 million light-years away, the telescope revealed a massive stellar stream, a river of stars stretching 163,000 light-years across space. This stream is roughly comparable to the diameter of our entire Milky Way galaxy. What makes this discovery particularly fascinating is that amateur astronomers had actually captured hints of this stellar stream before, but the professional astronomical community had never confirmed its existence. It took Rubin's unique sensitivity to low surface brightness objects to finally reveal this cosmic structure in all its glory. Stellar streams like this form when smaller galaxies get too close to larger ones. The gravitational forces literally tear the smaller galaxy apart, spreading its stars across vast distances in space. Sarah Pearson, an astrophysicist at the University of Copenhagen, explained that this is the first stellar stream detected from Rubin. The discovery suggests that this ancient galactic collision may have been responsible for triggering the bar formation, starburst activity, and active galactic nucleus we see in M61 today. The implications are staggering. If Rubin can find a stellar stream around a well-studied galaxy like M61 in its very first observations, imagine what it will discover when it begins its full 10-year survey. Aaron Romanowski, who led the research team that published the discovery, concluded that when Rubin obtains very deep imaging of galaxies, we'll see them surrounded by a faint network of stellar streams. But stellar streams are just the beginning. In January 2026, Rubin made another record-breaking discovery that showcased its ability to find extreme objects in our own solar system. Using data from those first 10 hours of observation, astronomers discovered 2,104 previously unknown asteroids, including one that's breaking all the rules. This asteroid, designated 2025 MN45, spins faster than any large asteroid ever discovered. At 710 meters in diameter, roughly the size of 8 football fields, it completes a full rotation every 1.88 minutes. To put this in perspective, imagine a Ferris wheel 10 times taller than the Seattle Great Wheel, spinning twice as fast. Who leads Rubin's Near-Earth Objects Working Group, colorfully described it by saying if you were standing on it, it would probably be quite the ride. What's remarkable about 2025 MN45 is that it shouldn't be able to spin this fast and stay in one piece. Most asteroids are essentially rubble piles, loose collections of rocks held together by weak gravity. An object spinning this rapidly should fly apart unless it's made of something much stronger. Greenstreet explained that this asteroid must be made of material that has very high strength in order to keep it in one piece. They calculate that it would need a cohesive strength similar to that of solid rock. These early discoveries are just a taste of what's to come. When Rubin begins its full legacy survey of space and time in early 2026, it will scan the entire southern sky every few nights for 10 years, generating approximately 20 terabytes of data each night. By the end of the survey, Rubin will have captured images of roughly 20 billion galaxies, 17 billion stars, and 6 million small solar system bodies. The asteroid discoveries alone will be transformative. Currently, all ground and space-based observatories combined discover about 20,000 asteroids per year. Rubin found over 2,000 in just 10 hours of observation. Over its 10-year mission, it's expected to discover more than 5 million asteroids, including around 100,000 near-Earth objects that could potentially pose a threat to our planet. But perhaps the most intriguing possibility is Rubin's potential to solve one of astronomy's greatest mysteries, the existence of Planet 9. For years, astronomers have noticed that certain objects in the outer reaches of our solar system have strangely clustered orbits. The best explanation for this clustering is the gravitational influence of a large, undiscovered planet lurking in the distant darkness beyond Neptune. Mike Brown, the Caltech astronomer who first proposed Planet 9, is optimistic about Rubin's chances. He said if you were to hand him a big wad of cash and say go build a telescope to either find this Planet 9 or find the best evidence possible for it, he would probably go and build the Vera Rubin Observatory. Scott Shepard from Carnegie Science estimates that if Planet 9 exists, Rubin has a 70 to 80% chance of finding it. The search won't be easy. Planet 9, if it exists, is likely between 5 and 10 times the mass of Earth, but it could be anywhere from 400 to 800 astronomical units away from the Sun, so distant that it would take between 10,000 and 20,000 years to complete a single orbit. At that distance, even a planet-sized object would appear incredibly faint, potentially right at the edge of Rubin's detection capabilities. Not everyone is convinced Planet 9 exists. Samantha Lawler from the University of Regina remains skeptical, pointing out that there are strong observational biases in the extreme trans-Neptunian objects that we need to be very careful about. The objects that suggest Planet 9's existence are so faint and distant that they've only been observed when they happen to be in certain areas of the sky, potentially skewing our understanding of their true distribution. Beyond these specific discoveries, Rubin represents a fundamental shift in how we study the universe. Traditional astronomy has focused on taking detailed pictures of specific objects. Rubin will instead create a constantly updated movie of the entire sky, capturing every change, every explosion, every passing asteroid. This approach will revolutionize our understanding of variable stars, supernovae, and other transient phenomena. The observatory will also excel at detecting interstellar visitors, objects from other star systems that occasionally pass through our cosmic neighborhood. These mysterious wanderers, like the cigar-shaped Oumuamua discovered in 2017, offer precious glimpses into the composition and history of distant solar systems. Zeljko Ivezic, director of Rubin Observatory construction, reflected on the first image release, saying it represents the culmination of about 2 decades of dedication, innovation, and collaboration by a global team. With construction now complete, we're turning our eyes fully to the sky, not just to take images, but to begin a whole new era of discovery. The scale of what Rubin will accomplish is almost incomprehensible. NSF Director Brian Stone noted that NSF-DOE Rubin Observatory will capture more information about our universe than all optical telescopes throughout history combined. Over its 10-year survey, it will generate approximately 500 petabytes of data, enough information to fill millions of laptops. The first images from Vera Rubin Observatory have already shown us hidden stellar streams, record-breaking asteroids, and millions of previously unknown cosmic objects. They've demonstrated that even in our well-studied local universe, profound discoveries await those with the tools to see what was always there, but hidden in the darkness. As we stand on the threshold of Rubin's full operations, we're reminded of Vera Rubin's own words about the nature of scientific discovery. She said, "We have peered into a new world and have seen that it is more mysterious and complex than we had imagined. The observatory that bears her name promises to peer even deeper into that mysterious cosmos, revealing secrets that have been waiting billions of years for someone to find them. The universe just became a much more interesting place."